In 2021, a luxury high-rise in Florida collapsed in seconds. In 2011, parts of Tokyo literally turned into liquid during a massive earthquake. We call these soil liquefaction events, a terrifying geological phenomenon, where the earth beneath your feet stops acting like a rock and starts acting like water. But long before we had seismic sensors or satellite mapping, an ancient record described a man so wealthy, his estate was a fortress, only for the ground to subduct and consume him vertically. To a skeptic, it sounds like a classic moral myth, but to a geologist in 2026, the description is uncomfortably accurate. Welcome to Proof Vault, where science and history meet knowledge. Today, we're investigating the case of Qarun. We're going beyond the Sunday school stories to look at the archaeological papyri, the tectonic plates of the Nile, and a 1,400-year-old text that seems to have understood physics 13 centuries before we did. Subscribe, because this episode might just change the way you see the ground you're standing on. To understand who Qarun was, we have to look past the robes and the desert sand. In modern terms, he wasn't just a rich guy, he was a tier 1 disruptor. While his peers were trading goats and grain, Qarun had moved into unrestricted liquidity. He was likely a high-level administrator for the pharaoh, a man who had mastered the grind set of the Bronze Age. The Quran mentions a detail that is physically staggering. It says he possessed treasures so vast that the keys alone would burden a company of strong men. Think about the physics of that statement. If the keys, the mere access points, were that heavy, what does that tell us about the scale of the vaults? We're talking about a level of accumulation that rivaled the state treasury of Egypt. This wasn't just savings. This was a monopoly on resources. But it's his mindset that feels eerily 2026. When people warned him to be humble, his response was a classic Wall Street defense. I have been given this only because of the knowledge I possess. Sound familiar? It's the ultimate self-made myth. He believed his success was purely a result of his superior intellect, ignoring the geological and social systems supporting him. He thought he was untouchable because he was smarter than the system. He didn't realize that the very knowledge he boasted of was about to be tested by a branch of science he didn't even know existed: geophysics. Every crime has a scene. For the story of Qarun, that scene is the Faiyum Basin, a geographic anomaly. 62 miles south of Cairo. To a casual tourist, it's a beautiful oasis. But to a geologist, it's a depression. The floor of this basin sits up to 140 feet below sea level. Why is that important? Because in the ancient world, if you were building a fortress of wealth, you wanted it here. Faiyum was the crown jewel of Egypt's agricultural empire, a high-stakes hub of trade, taxation, and elite privilege. Skeptics often argue that Qarun is a fictional character, but the archaeology tells a different story. In the early 20th century, British archaeologist Dr. B.P. Grenfell unearthed Ptolemaic-era papyri in this very region that mentioned an elite figure named Qarun. This wasn't just a name in a book. This was a man linked to massive trade routes and temple wealth. Today, the massive saltwater lake in the center of the depression still carries his name, Birket Qarun, Lake Qarun. In a land obsessed with preserving the names of pharaohs, why does this specific lake and a nearby ruined temple bear the name of a man of greed from a 1,400-year-old text? Now, here is where the mystery turns into physics. Geologically, the Faiyum isn't just a hole in the ground. It's a structurally controlled tectonic basin. It sits on a pull-apart fault system. For centuries, people thought the depression was carved by wind, but modern seismic mapping shows it was created by tectonic tensile forces. The ground here is literally pulling apart at the seams. It is a landscape designed for subduction, a place where the earth doesn't just crack, it unzips. If you were going to record a story about a man being swallowed by the earth, this is the only place. In Egypt, where the geology actually makes that a scientific possibility. To a skeptic, ancient texts often feel like a game of telephone, stories that change as they pass through different cultures. If we look at the earlier biblical account in Numbers 16, the story of Korah is filled with what historians call tribal drama. It describes a massive rebellion of 250 men, holy censers, and a divine fire that consumes the leaders. The destruction is horizontal, a battle of authority between men. It's a compelling story, but for a scientist, it's hard to verify. But when we look at the Quranic account, 1,400 years later, something fascinating happens. The forensic focus shifts. The Quran strips away the 250 men, the fire, and the tribal infighting. Instead, it narrows the lens down to two very specific variables: extreme wealth and vertical subduction. It doesn't describe a war, it describes a structural failure. It states that the earth didn't just open a mouth, but that it kasafna, a very specific Arabic term that describes the ground losing its integrity and swallowing a structure whole. For a Western skeptic, this is where the needle moves. We're no longer talking about a religious polemic. We're looking at a geotechnical case study. The Quran ignores the magic and focuses on the mechanism. It claims that the man and his home, the literal foundations of his power, sank into the earth by removing the cultural noise of the Bronze Age. The text provides a description that we can actually test in a lab. It's as if the record was cleaned of its myths, to leave only the raw, physical data. And that data points to a phenomenon that modern civil engineers fear. In the 7th century, the Quran uses a precise verb to describe the billionaire's end, kasafna. Most assume this is poetic flair, but in the world of civil engineering, it's a technical term. For seismic subduction, for 13 centuries, the world thought earthquakes only made buildings fall down. It wasn't until 1953 that two Japanese researchers, Mogami and Kubo, finally gave this phenomenon a name: soil liquefaction. Mogami and Kubo discovered that when the earth vibrates, the water pressure between sand grains rises. Suddenly, the ground loses its sheer strength. It stops acting like a solid and starts acting like a thick liquid. Notice the physics here. The buildings don't crumble, they subduct. This is exactly what the Khasaf verb describes: a vertical inhaling of a structure. In a desert environment like Faiyum, where the water table is high and the soil is sandy, this isn't just a possibility. It's a geotechnical certainty during a seismic event. Here is the problem for the skeptic. Before the 1950s, the physics of sinking was an unknown field. We had no mathematical models for how soil becomes liquid. Yet, 1,400 years ago, a man in the Arabian desert, thousands of miles from a geology lab, didn't say the house was knocked down or burned. He used a word that specifically describes the vertical loss of ground integrity. How does an ancient record skip 14 centuries of trial and error science to land on the exact terminology we use in modern disaster mitigation? To a skeptic, it's a lucky guess. To a physicist, it's a recorded anomaly. But the physics of the how is only half the story. We need to look at the where. For decades, the Sunken Palace was considered a campfire story, but the archaeology tells a different tale. Mid-20th century Egyptologist Dr. Ahmed Fakhri documented something anomalous in the Fayyum. Ruins that didn't just crumble, they dropped. Unlike most ancient sites that are buried by blowing sand, these structures sit dozens of feet below the original ground level. Local Bedouins still point to areas in the lake where, during low tide, the outlines of a dead city appear beneath the waves. Modern satellite data from the Egyptian Geological Authority has finally confirmed why. The Fayyum is a pull-apart basin. a place where the Earth's crust is literally being stretched. Mapping reveals massive tectonic fissures, deep scars in the bedrock, located exactly where. The local legends place the Palace of Qarun. These aren't just cracks, they are subduction throats. This is the smoking gun. In a standard ruins site, you find debris scattered horizontally. But here, the sensors show vertical displacement. The buildings are still there. They've just been inhaled into the tectonic fissures. The geography matches the physics, and the physics matches the text. The only thing left to explain is the probability. Now let's talk about the math. What are the odds? You have a 7th century record revealed in a desert where earth science didn't exist, describing a billionaire in a specific Egyptian basin. If this were just a moral myth, the narrator would have said he was struck by lightning. Events everyone understands. Instead, it chooses the one rare geotechnical event, seismic subduction, that actually happens in that specific geographic location. Here is the challenge. Modern science didn't even have a name for this until Mogami and Kubo sat down in a lab in the 1950s. We needed high-speed sensors and vibration tables to understand the physics of Khasaf. Yet, the text got the physics right 14 centuries before. The first textbook on soil mechanics was ever written. If this is just an ancient story, why does it have the precision of a modern field report? How does a text written 1,400 years ago describe a phenomenon we only just categorized? It's easy to dismiss a myth, but it's much harder to dismiss the data. The physics are there. The geography is there. The how is the only thing that remains. We live in an era where we demand proof for everything. We have satellites that can read, a license plate from space, and sensors that can feel the Earth move a fraction of a millimeter. Yet, when we point these modern tools at the Faiyum Basin, they confirm a story that was already written, while the rest of the world was still debating if the Earth was flat. This leaves us with one uncomfortable question. How did the Qarun, a text written 1,400 years ago, know the specific physical mechanisms of a disaster that modern science has only just now discovered? Was it a 1 in a billion lucky guess, or are we looking at a source of knowledge that doesn't follow our timeline? Subscribe, because the next episode might just change the way you see history.